Hello everyone. Welcome to another episode of Homework Help with Mr. Math. We have received a set of exercises. These are a system of equations that needs to be resolved by substitution. Okay, so we want to give you a hand. Let's start. Okay, first exercise says y equals, here's our system, and this is y equals to 2x minus 1 and 2x plus 2y equals to 22. Okay, that is our first exercise in there. Let's see what we can do. Okay, we're going to give numbers to our equations, equation 1 and equation 2. As we can see, equation 1, it's already we already have y isolated, one of the variables, so that's the one that we will replace on the second one. Now equation 2, right, it's 2x plus 2y equals to 22. Since all of these coefficients, 2, 2, and 22 are divisible by 2, that's exactly what we're going to do. We're going to divide each element of the equation by 2. So our new equation 2 is going to be x plus just y equals to 11. Now, what are we going to do in here? We're going to use the definition of equation 1, what it says y equals to 2x minus 1, we're going to use on this equation 2. Okay, so we have x plus 2x minus 1 equals to 11. We'll have x plus 2x minus 1 equals to 11. So we have x plus 2x, 3x minus 1 equals to 11. We're going to add 1 on both sides. And then we'll have 3x equals to 12. Let's divide by 3, both sides. And we have x equals to 4. That's the first part. We just found x equals to 4 as the solution. Now we're going to take this result and we'll plug into equation 1. Remember what equation 1 says? Y equals to 2x minus 1. Okay, so it'll be y equals to 2 times 4 minus 1. Y is equals to 2 times 4, that is 8 minus 1. Y is equals to 7. So the solution will be y. X equals to 4, y is equals to 7. All right, let's go to the next exercise. Next one says negative x plus y, that's our first equation, is equals to negative 13, and 3x minus y is equals to 19. Okay, again, we're following the same process. We're saying equation 1 and equation 2. Okay, we need to select which one we want to work first and which one we want to isolate a variable from. So we're going to select equation 1 just because it looks to be the easier one. So equation 1 will be negative x plus y equals to negative 13. Let's add x on both sides. And we'll have y equals to x minus 13. Now what do we need to do with this variable y equals to x minus 13? What we're going to say is equation 1, which is this equivalence, right? We're going to use it on equation 2. So what is equation 2? It's 3x minus y equals to 19. Okay, so we'll have 3x minus x minus 13 equals to 19. We'll have 3x, this negative at front, we'll make negative everything on the parentheses. Will be negative x plus 13 equals to 19. 3x minus x, that is 2x, plus 13 equals to 19. Let's subtract 13 on both sides. This is gone, and we have 2x equals to 6 divided by 2 on both sides, and we have x equals to 3. That's our first answer. Knowing that x is equals to 3, we can go back to either equation 1 or equation 2, but uh, the easy path in here is to go back to this equation right here, y equals to x minus 13. So if we use this one, we have y equals to x minus 13, and then we know that x is 3 minus 13, then y should be equals to negative 10. Let me move this up a little bit. Y should be equals to negative 10. Okay, so our solution for the problem, solution, should be what? X equals to 3 and y equals to negative 10. Okay, let's go to exercise number 3. Don't forget to visit www.gomrmath.com. You can upload your questions, you can send your requests. I'll be happy to helping you. Next one, it says 2x plus y equals to negative 12, and negative 4x minus 2y equals to 30. Okay, let's start thinking a little bit what we can do here. Just let me make sure that we copy right. That is 2x plus y negative 12, and negative 4x minus 2y equals to 30. Okay, remember what we were asked to do here is to solve by substitution. Okay, so from the first equation, again, let's give names, equation 1 and 2. From the first equation, I want to isolate y. It's not that this is a rule that we have to isolate y. It's just because it's an easy way right now. Because if we isolate x, we'll need to have everything divided by 2. So we don't want to do that. From equation 1, we have 2x plus y equals to negative 12. Subtract 2x on both sides. And we have y equals negative 2x minus 12. We have that one, right? From equation 1. Now we will plug this equation 1 into equation 2. What is equation 2? Negative 4x minus 2y equals to 30. One more time. All of these coefficients are divisible by 2. So let's divide all of those, I would say by negative 2 if we want. So we will convert these two variables here into positive. If we divide by negative 2, by negative 2, and by negative 2. Okay, this one here will make 2x. Negative 2 divided by negative 2, that is 1. Y equals to 30 divided by negative 2, that is negative 15. Okay, now let's use the y that we just found out in here. So we'll have 2x plus, what is this y? Should be negative 2x minus 12 equals to negative 15. So we'll have 2x, positive times negative is negative, negative 2x, positive times negative is negative, negative 12 equals to negative 15. So 2x minus 2x will cancel out, and then we'll have negative 12 equals to negative 15. What happens there? So this is for sure false, right? When at the end of the substitution, okay, following all of these processes, we find something that is inconsistent, we say that the system has no solution. Okay, there's no solution for the system. Now I want to show you how to recognize when we don't have a solution for the system before we even start working on it. The order on these problems is clear, is asking us to solve by substitution, and then at the end say if there is one solution, no solution, or infinitely many solutions. But we can know that from the beginning, like before we start, we can know that. And How do we know that? It's very simple. We have to change both equations to this form, y equals mx plus b, the slope intercept form. When we change to this form both equations, it's very simple because we will be able to recognize the slopes. If the slopes are the same, we're talking about parallel lines. And remember, just quick refreshing here. When we are working on a system of equations, let me take another color in here, right? Let's suppose that we have a plane in there, right? So one equation is here. I'm gonna put it on green, and the other equation, I'm gonna put it over here, right there. So the solution of this system is happening right here. Whenever these two lines encounter, whenever these two lines intersect, that the coordinates of x and y of that point are the solution. Okay, don't kill me. Okay, don't kill me. It will be x, negative x, y, and negative y. Okay, so here, that's the solution of any system of equations. What happens when these lines are parallel? What would happen? We have something like this. Okay, negative x, negative y. What do we have? We have a line that looks like this and another line that is exactly like that. So there is no point where these two lines will encounter one to each other when these two lines intersect to each other. How do we know that? How do we know when this is happening? It's because of the slope. So the slope of this line, if we call this line 1 and this one line 2, the slope 1 and the slope 2 are here. And the slope 1 has to be equals to slope 2. This is telling me that both lines are parallel. So let's go back to our exercise a little bit. So we have the first one, 2x plus y equals to negative 12. And second one, negative 4x minus 2y equals to 30. Okay, remember, our exercise was done here. This is just an extra explanation for you. Okay, with those two equations, I want to transform and I want to convert to this form, to the form y equals mx plus b, also known as the slope intercept form. So I'm going to take equation 1 from here, and I'm going to say 2x plus y equals to negative 12 minus 2x. I think we already did that. So y is equals to negative 2x minus 12. From here, we just find out that this slope is what? Put it over here. This slope is negative 2, right? Let's take equation 2 from here. We have negative 4x minus 2y equals to 30. Remember that we divide by negative 2 everything. We have 2x plus y equals to negative 15 minus 2x, and we have y, that will cancel out, equals to negative 2x minus 15. Look, what is the slope in here? Ah! Let's continue with red. Okay, look, it's negative 2 and negative 2. So since these two lines match the slope, that means that these two lines are parallel. That's why we are okay saying there is no solution for this system. Okay, great. Let's go. We're halfway through. Okay, so let's go to the next exercise. What do we have in there? Okay, so the next one, it says for our system, 1/3 y equals to 7/3 x plus 5/3. Okay, and the second one, it says x minus 3y equals to 5. Always verify whenever you're copying this from your books or from any text or something. Always verify that you're copying everything right, because from time to time we can find um, some mistakes that we're just copying wrong, and that will change everything. Okay, no, everything looks correct. So let's again name equation 1 and equation 2. Okay, so it seems like equation 1, it's y, 1/3 y equals to something. So it looks like it'll be the easiest one to isolate y and then replace that on equation 2. But we have 1/3, 7/3, 5/3. Now remember that whenever you have a equation like this, you can multiply by the same number or divide by the same number on both sides of the equation. So that's what we're going to do with equation 1. We have 1/3 y equals to 7/3 x plus 5/3. What I want to do, I want to multiply times 3 on both sides. Okay, I'm not changing anything because I'm multiplying times 3. On the first part, look, this will cancel out. Now I'm going to distribute this 3 for both. It will cancel out this one, and it'll be 7x. It will cancel out this one, and I'll make 5. It's a lot better for us. Like it's very it's beneficial. Yeah, it's what we need. So now we will replace this one. That is equation 1 is equivalent. This is exactly the same of saying this part in here. Equation 1. These two equations are exactly the same. Looks different, but represent the same. If we graph those two, it represents exactly the same. And we'll replace this equation 1 into equation 2. So equation 2 is x minus 3y equals to 5. Remember, y now is 7x plus 5. So x minus 3 times 7x plus 5 equals to 5. Okay, what do we have in here? X minus 3 times 7 is 21x. Negative 3 times 5 is negative 15 equals to 5. X minus 21 is negative 20. X minus 15 equals to 5. Let's add 15 on both sides of the equation. And we have negative 20x equals to 20. Divided by negative 20 on both sides. This will cancel out. And we'll have x equals to negative 1. Perfect. First part of the equation. With this x equals to negative 1, we will replace on the one that we find out in here. It says what? Y equals to 7x plus 5. We know that x is equals to negative 1. Y is equals to 7 times negative 1 plus 5. Y is equals to negative 7 plus 5. Y should be equals to negative 2. Okay, so our solution for this solution. I didn't forget then this time. X equals negative 1. Y equals to negative 2. All right, that will be the fourth one. Okay, let's go to our next exercise. Okay, number 5. It says y equals 2x minus 7 and 3x minus 3y equals to 21. Again, equation 1, equation 2. You see the process is exactly the same. We have both equations. We need to isolate one of the variables in one of the equations and then replace on the other one. On many times and many occasions, we already have this one isolated or one of the variables isolated. Everything that we're doing today, it doesn't mean that we always have to isolate y. That's not accurate. It means that one of the variables needs to be isolated and replaced in the other equation. It could be x, right? It's not necessary y. But since we already have there, like, let's take advantage, and let's say our equation 1 will be plugged into equation 2. What is equation 2? Is 3x minus 3y equals to 21. Now look that all of these coefficients are divisible by 3. So let's do that. We'll have x minus y equals to 7. And now in here, let's replace our y equals x minus 7. So we'll have x minus 7 equals to 7. We'll have x minus x plus 7 equals to 7. X minus x will cancel out, and then we have 7 equals to 7. Again, is a little similar of what happened a little bit ago, and we can show that as well. Remember when we say we don't have any solution, the variable was eliminated in there. So, but look at the difference. In the previous one that we say no solution, look at here the difference. We have negative 12 equals to negative 15, which is inconsistent, so we say no solution. But in this case, we have 7 equals to 7. It's something that is true, right? When this happens, we say that this equation have infinitely many solutions. Again, why this happens? Because if um, we alter and if we massage these equations a little bit, we can find that um, both equations are exactly the same. That is the situation. Since both equations are exactly the same, so you have one equation and two variables. That is your sign and that is your cue for this, for the infinite many solutions. So let's do that. We have equation 1, y equals to x minus 7, and 3x minus 3y equals to 21. We know that from equation 1, we can just subtract x. We want to put it on the same way. We want to subtract x, and we'll have y equals to x minus 7. Let's subtract x on both sides. We'll have y minus x equals to negative 7. Let's multiply everything times negative 1 and put it in order. We'll have x minus y equals to 7. That is our equation 1. Now let's see equation 2. 3x minus 3y equals to 21. Remember that we divide by 3, and this was our result, which is x minus y equals to 7. Look, equation 1 and equation 2 are exactly the same equation. Both are exactly the same. That means that you have only one equation, but two variables. So you have infinitely many solutions. Okay, let's go to our last exercise. Okay, it says 3x plus y equals to negative 13 and negative 2x plus 5y equals to negative 54. Okay, good. So again, exactly same concept. Let's use equation. We have equation 1 and equation 2. We have to use one of the equations, whatever is this one, whatever we want, if it's 1 or 2, isolate one of the variables and replace on the second equation. So let's take equation 1. It's going to be the easy one. So we'll have 3x plus y equals to negative 13. Okay, let's subtract 3x on both sides. Then we'll have y equals to negative 3x minus 13. Let's put that negative right in there. Okay, so what do we do now? We just saw in the previous 5 exercises. What we have to do is just to replace into equation 2. That it says negative 2x plus 5y equals to negative 54. Okay, so we have negative 2x plus 5, but we're going to use now what is y. Negative 3x minus 13 equals to negative 54. We'll have negative 2x. 5 times negative 3, what is that? Is negative 15, right? Negative 15x. What else we have? 5 times negative 13. It'll be negative. And what is 5 times negative 13? Is that 65? Yes. Equals to negative 54. So negative 2x minus 15x is negative 17x minus 65 equals to negative 54. Let's add 65 on both sides. This is gone. And then we'll have negative 17x equals to negative 54 plus 65. That is 11. Divide by negative 17 on both sides. And we have x equals to negative 11 over 17. And that is our answer. It doesn't look pretty, but that's our answer. Okay, now let's replace this one on what we found of y. Remember, we have this equation as equation 1. Let's replace there. Equation 1 says y equals negative 3x minus 13. Y is equals to negative 3. But what is x? Negative 11 over 17 minus 13. Okay, y is equals to, we have hidden 1 in there, we don't see. So numerator times numerator, it's going to be a positive 33 over 17 minus 13. Okay, what is equals to 13 over 17 minus 13. That is negative 188 over 17. Again, ugly answer. That is actually a negative 11 point something. But is the answer, right? There's nothing we can do. Okay, let's put our solution in here. Our solution is x equals to negative 11 over 17. That is for x. And y will be negative 188 over 17. Okay, that will be the solution for this part in here, for this problem. Okay, so those were the 6 exercises that we did for you today. Thank you very much for watching. Remember, go visit gomrmath.com. Just let us know what you need, what help you need. We'll be glad helping you. Thank you very much for watching.